So this is the 2016 Junior Cert Higher Level Paper 1 and we're looking at question number 9. Part A says write each of the following numbers in the form 3 to the power of k, where k is an element of the set Q, that's a set of rational numbers. So any number that can be written as a fraction. Okay, well, the first one is number 9, and we know 9 can be written as 3 squared, or 3 to the power of 2. So 2 is an element of the set of rational numbers. The second one is the number 1, and we should know that any number raised to the power of 0 is 1, so we could write 1 as 3 to the power of 0. So the rules of indices that you should be using to guide you through this are in your tables book. So we have down here the square root of 27. Okay, so square root of 27. Well, the first thing is we need to get the 27 down to the base 3, so that becomes square root of 27 is actually just 3 cubed. 3 by 3, which is 9 by 3 again, which is 27. So it's the square root of 3 cubed. And square root can be written as the square root of a number is that number to the power of a half. In other words, the square root of a is equal to a to the power of a half from the tables. So that means that it's going to be 3 cubed. That's going to be to the power of a half. That's another way to write that. And then we can apply our law of indices that says a to the power of m, with n outside the bracket, is just a to the power of m times n. So you're allowed to multiply these two numbers. So that becomes 3 to the power of 3 multiplied by half, so it's 3 to the power of 1.5, or 3 to the power of 3 over 2 if you like, but 1.5 is an element of the set Q, so we're finished there. Number 4, 1 over the cube root of 3. Okay, so 1 over the cube root of 3, well, that's equal to 1 over 3 to the power of a third. The cube root of a number can be written as that number to the power of a third. And then if we have 1 over a base to a power, we can use the rule in our tables book. 1 over a to the power of p is equal to a to the power of negative p. So 1 over 3 to the power of a third is equal to 3 to the power of negative third. And minus a third is an element of the set of rational numbers. Okay, part B says write the number minus 2n all to the power of 4. Write that in the form a n to the power of b, where a and b are elements of the set of integers, the z set. Well, minus 2n to the power of 4, that is minus 2n by itself 4 times. So minus 2n multiplied by minus 2n, well, that gives us 4n squared. And over here we get another 4n squared. And when we multiply them, we get 16n to the power of 4, which is in the form a n to the power of b, because a and b are 16 and 4, which are integers. Part C says x and the square root of x squared are not always equal. Give an example of a value of x and the corresponding value of the square root of x squared, which are not equal. Well, we know, for instance, that 3 would be equal to the square root of 3 squared. 3 squared is 9, and the square root of 9 is 3. So 3 is equal to the square root of 3 squared, so it works for the number 3. However, if we tried a negative number, so let's say we tried negative 3, is negative 3, is that equal to the square root of negative 3 squared? And we see that negative 3 is equal to, that's saying that negative 3 is equal to the square root of 9, which is 3. And minus 3 is not equal to 3. So the answer then would be minus 3 for x would give a value of 3 for the square root of minus 3 squared. The same can be said for any negative number. And that's the end of question number 9.